This question is from GATE 2013 Mechanical Engineering paper, question number 52. In orthogonal turning of a bar of 100 mm diameter with a feed of 0.25 mm per revolution, depth of cut of 4 mm and cutting velocity of 90 meter per minute, it is observed that the main tangential cutting force is perpendicular to the friction force acting at the chip tool interface. The main tangential cutting force is 1500 Newton. The orthogonal rake angle of the cutting tool in degree is dash. Let's see what it is. So here we'll have to draw a force diagram depending upon the orientation of the tool. It's given that this is an example of orthogonal turning. So in orthogonal turning we have Fc, the cutting force, is perpendicular to Ft, which is the tangential force. So if let's say this is the tool, rake angle is nothing but the angle at which this tool is being placed with respect to this vertical line, so which is alpha. Now let's draw the force diagrams. Whatever is the orientation of tool, cutting force will always be in this direction, Fc. Then for orthogonal turning we have this force Ft perpendicular to Fc. We have the friction force in this direction. So this friction force is such that this will also make an angle equal to alpha with the vertical axis but on the opposite side. Now we can plot the normal reaction like this, perpendicular to the friction force as always. So this angle is 90 degree, this is 90 degree, this is friction force F and this is the normal reaction N. Therefore, the resultant can be shown like this. Also, the angle between normal reaction and resultant is beta. So we can write down these two angles. This angle in this triangle will be beta plus 90 degree subtracted from 180. So this angle will be 180 minus beta plus 90, which is nothing but 180 minus 90, that is 90 minus beta. So this angle we got as 90 minus beta, and therefore this angle can be calculated as, this total is 90. So we have 90 minus alpha plus this one, which is 90 minus beta. So this angle turns out to be 90 minus 90, 0, minus alpha plus beta. So this is nothing but beta minus alpha. So this yellow angle is beta minus alpha, green one is 90 minus beta, and red one is alpha. Now it is given that cutting force is perpendicular to the friction force. This is a general diagram in which we did not show Fc perpendicular to F, but for a condition where Fc will be perpendicular to F, sum of the yellow angle and the green angle should be 90 degrees. So therefore we have beta minus alpha plus 90 minus beta should be equal to 90. From here we get 90 from both sides cancels out because this will give us 0, 90 minus 90, 0. Beta minus beta is also 0. So we have the answer as minus alpha equal to 0. That is nothing but alpha will be equal to 0 degree. So we have the rake angle value to be 0 degree. Let's go back and mark the correct option. The orthogonal rake angle of cutting tool for this particular condition where main tangential cutting force is perpendicular to the friction force, we have orthogonal rake angle as 0 degree. For further studying orthogonal cutting, you can refer to the NPTEL video Lecture 6 Orthogonal and Oblique Cutting from the course lecture series on Manufacturing Processes 2. You can also find the details of diagram that we have drawn here. This course is by Professor A.B. Chattopadhyay, Professor A.K. Chattopadhyay and Professor S. Paul. They are from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.